What if a new planet, 120 light years away, could be the key to life beyond Earth? Thanks to the James Webb Space Telescope, we've just...
Hello, do this video about the new discovery. The Webb Telescope satellite has discovered a planet 120 light years away that retains a lot of water. In that water they have organisms that retain life. With these organisms we wouldn't live. It's in our water. They help preserve life. So they're thinking that this is a red flag for the first discovery about life in off this planet, off world. I'm doing this video because it came to me. We're talking about light years, 120 light years. Relativity doesn't mention measurements about distance and time and distances in his theory, GRT. Okay, he did make equals mc square the equation for matter, energy, and in his book he doesn't mention any type of measurements. This I don't know why this is. I don't understand why he would say there's a universal speed limit and not include some kind of mathematical formula to break down the essence of light years. He wrote his book in 1915, GRT, General Relativity, and about 8 years later found out the universe was expanding. So we have the Erwin Hubble universe. My books are EVG, which is expanse space gravity, or expanse vacuum gravity. It's a new book that I put out. In essence, it explains, it's an extension to Edwin Hubble's universe expansion theory. We go into space expansion, exactly what that is. Relativity has been an idea in my mind since I was young, let's say 15, 16, whatever. And I always question the idea if it's a vacuum up there. How could we be limited to a gravity that measures 0-point energy, where relativity takes the Earth science of 9.8 meters gravity force and extends it to 0-point space gravity. This I don't understand. And he never broke down the idea about what light years are. I don't even think he mentioned it. I don't think he knew very much about mathematics. From the patent office, he went to Princeton University, where he developed the Rosenberg Bridge, I think it's called, which is equations for bending space, which another, how can you bend something you can't touch, that has no energy to it? Of course, he explains it as a fabric, but I think it's still three-dimensional, and it's a vacuum, an empty vacuum. And But he made no breakdown of light years, you know. Light years is years in seconds. 1 second. Break it down to 120 light years. That's 120 years squared. Oh, dang, it's pretty close. I do mention some kind of breakdown in my books about that. Why? I don't think he was very informed mathematically. He wrote his book E equals MC squared, that actually comes from P equals MC squared, which is evidence of properties. But I look at it as an extension for propulsion. So anyways, they found a planet 120 light years away, which is pretty far. And as part of the newsreel, there's no breakdown. I don't even see. I think Einstein. So you got to understand, this was 1920. So his diameter of the universe is the speed of light. Gravity. So the speed of light's cut in half due to Earth's gravity at 9.8 meters a second. In other words, he speculates the diameter of the universe as being 93 billion miles across. 93,000 billion. Or actually, I think he says 93 billion in diameter, which is the mass relative to velocity in relationship to Earth's gravity. In other words, the speed of light in space is the speed of light. Under the Earth's gravity force, we can only travel at 93,000 miles a second. But he takes that and uses it for the diameter of the universe. Now, I think it's three-dimensional. The diameter is across. The flat surface, flat universe. I think he was talking about at that time, and it's three-dimensional. It's round. So you got 3 times those numbers for the diameter of the Earth or the radius. Now, this planet that they discovered has water in it. It has life organisms in it. I know from a telescope it's only a sight, but since there's water in it, then it has to have these microorganisms in it, and that points to a red flag for life on or at one time in the universe, in our exploration of the universe. Now, going off world, let's talk a little bit about Elon Musk, his ideas of going to the moon and trying to find water. Or not the moon, Mars. I don't know why he wants to go to Mars. Now, they have a machine that makes water, actual water, and it takes it right out of the atmosphere. Now, if you go on a moon and the atmosphere is less than Earth's atmosphere by 10 points, whatever you want to call it, a much colder environment, you got water. You're going to have water and more of it than the machine takes here on Earth. So why he wants to go to Mars, I don't get it. Maybe that's just a tag he uses just for his explanation with creating satellites and such to go to Mars and check that out. But as a lift station, I think the moon is the best place to go for future space exploration. What a better place to stand up a space station to explore the rest of the universe. Now, Elon Musk, his ideas about out space seem to be, the guy's getting into everything, even politics. But he is supposedly the richest single man, I guess, man in the world. And with all that money, I guess he could do a lot of things. But that's my idea how the future should be set up, and I do have a lot of explanations about setups and stuff with what I know and realize about our own planet here and how it's changing. We're going into a more technology type change with AI and computers and artificial intelligence. But when they talked about the discovery and how far it was, 120 light years, when I researched relativity, there's no mathematical, just the E equals mc squared. And I couldn't understand that. I guess maybe his math he wasn't so good at math, and later when he got into the university he learned mathematical injunctions to his theory. That's what I think myself. I have researched the science of space travel. I guess that's why I'm hooked on relativity. It's more of he took the universal speed limit and created a universal speed limit to the speed of light, and then he took that speed limit and created a format for space time travel. Yet he has no equations for distances or equations to break down what the speed of light is, except that what I mentioned in the diameter of the universe. Now, the speed of light broke down by Earth's gravity is not the diameter of Earth or of the universe, let's say. So I'm wondering where he was going with all this, with the past and future. It was eight years later that Erwin Hubble discovered that the universe was expanding. Anything over the speed of light, anything moving, expanding, even though it's only 43 miles a second between the galaxies that they are separating, is enough to say the speed of light is not constant. My extension goes into the idea of how much energy or pressure it would take to do that. And with that, I can change the speed limit, because those equations and answering that question gives us a new speed limit in the same way that relativity did, or general relativity. So that's what I'm bringing forth in my video, or this video for YouTube. It's just the idea, another question in relativity, which isn't explained in the reality of his legacy of space travel. And I'll leave it at that. My name is Rod Kowicki. Thank you.